Hello, this is Ms. DB, and in this video we'll go over how to do a few of the problems from the 9.3 worksheet on finding the area of composite figures. Composite just means that you have two or more figures put together. Sometimes it's two rectangles put together, such as in this one. We could think about this as being either divided here into two rectangles or divided this way into two rectangles. Sometimes when you divide it, you have to figure the length or width that is missing. You can also have a composite figure that is made up of three figures put together, such as in this example we have a triangle, then we have this rectangle, and then we have this semicircle, which is a half circle. So that one would take a little while, but they're not difficult to find the area of each of these. Do remember that if you're doing something like finding the area of a semicircle, that's only half. So you would take 1/2 times pi r squared. Now you're going to need your list of formulas from earlier this chapter, or be looking in your book so that you can look them up as you need to. We'll mostly be working with triangles, rectangles, and semicircles, but there could be other figures, or you might divide your triangle in a way that, or not your triangle, but your figure in a way that makes sense to use maybe a trapezoid or something, or a parallelogram. Sometimes it's easier to find the area by subtracting a piece. So in example A here, we could find this by dividing this right here, maybe we could, and then say this is a trapezoid and this is a trapezoid. Yep, you'd be able, no, because we don't know this amount here, the height, so you wouldn't be able to do that, would you? We don't know that this is cut exactly in half. So instead, what we're going to do is find the area of the whole rectangle and then subtract the area of the triangle. In this one, you could find the area of the whole rectangle and then subtract the area of the two half circles, which together make a whole circle. So on the rest of the problems, you can decide the best way to divide your figure. Sometimes it will be by adding. Sometimes it might be by subtracting, like number 5, number 6. And sometimes either one would work just fine. Now on all of these problems, you have to show your work or you're not going to get any points. If you just write down an answer, I'm not even going to count it as correct because there's no way to do these without doing some work. If you want to do your work on another piece of paper and then take a picture of it and attach it, that's just fine. So do that if you don't want to write all your work on here. So I'm going to do number 1. I'm going to start this one. Now you can decide if you want to draw a line here and divide it into a little piece and the big rectangle, or maybe you want to divide it, let me move that over now, into this kind of skinny rectangle and this bigger rectangle. Either one will work correctly. And so there's more than one way to do pretty much all of these problems. When you divide it the way I have shown now, we don't know this amount here. So you're going to have to find that, but you can because we have that the whole base is 28, the whole bottom piece from here to here is 28, and from here to here is only 22. That means that 28 minus 22, 6, is the width of that skinnier rectangle. So the area of a rectangle is length times width, or base times height. And I have two rectangles. So the first one is 20 times 6, or 6 times 20, or 120. Now for the other rectangle, that's not 28 wide, but 22. So that would be 22 times 15. And then you'll have to get your calculator out. 15 times 22, or 22 times 15, is 330. And then the area of the whole figure would be found by adding those two amounts together. Let's look at another example. Let's look at number 3, or another one with a half of a circle like that. I'll start number 3. So in number 3, we have two figures. We have a semicircle and then we have a square. It's a square, not a rectangle, although you still find it with the same formula. So the area of a circle is pi r squared, but we only have half of that circle. So 1/2 pi r squared. And then we're going to add to that the area of the rectangle, or it's a special rectangle of a square, which is length times width, or side squared, because it is a square. So that would be 16 times 16, or 16 squared. And this one would be 1/2 pi times, what's the radius of this? Well, we know that from here to here is 16. The radius would be half of that. So this would be 1/2 pi times 8 squared. Remember to do the 8 squared first, and then multiply by pi, and then take half of that, which you could do by dividing by 2. And then we will add these two answers together to get our whole area. Let's look at number 5. In number 5, I'm going to try the subtraction method. So I'm going to look at the whole rectangle. The area of that is base times height. And then I'm going to subtract the area of the triangle, which is 1/2 base times height. So let's see if we can figure out the numbers here. Of the rectangle, the base is 22 and the height is 18. That one's easy enough. Now what about the triangle? The triangle, we have the base is from here to here. Well, that's equal to the base of the rectangle. That's the 22. The height of the triangle is not 18, only the 9 from here to here. So we will find this one, 22 times 18, and then we will subtract whatever 1/2 times 22 times 9 is. And that will be the area of the figure, for the shaded area of the figure. In number 7, you could use the area of a trapezoid for this, or you could divide it and find the area of the rectangle plus the area of the triangle plus the area of the other triangle. I think I'm going to go ahead and find the area of the trapezoid because I haven't used that formula today yet. So this piece right here is a trapezoid, and the area of a trapezoid is found by taking 1/2 base 1 plus base 2, and then and then multiplying the whole thing by the height. You could also take base 1 plus base 2 divided by 2 and then multiply by the height. And then I have an area of a triangle, which is 1/2 base times height. So this is the triangle part. This is the trapezoid part. And again, you could do this with triangle, rectangle, triangle as well. So for the trapezoid, base 1 is not this 30. I think that says 30. The height is the perpendicular distance between the bases. So the height has to be that 30, which means that the bases are 16 for one of them and 40 for the other one. It doesn't matter which one you call B1 and B2. And then the height is this distance here, which is the perpendicular distance between the two bases. So that's where the 30 goes. And then for the triangle, we have, what is this base? The base of this triangle is 16. The height is the perpendicular to that base, which is 30. We are not going to use the 34 at all. The 34 is not the height of the triangle, it's not the base of the triangle, it's the hypotenuse, but we don't use that to find the area. So these are the two formulas that you would use to find the area of each part and then add them together. All right, let's look at the next section, which is an application problem. This girl, Katie, is making a garden, and it's made up of these 3 figures together. And then there's a little bit extra on there. After you find the area of it, it says that it is going to use 17 gallons of water per square foot. So basically, once you find the area, which they do here, then you would multiply that by 17 to find how many gallons of water it needs. This problem is easier than that one above. It says Nick has to recreate a small metal plate to replace a piece from a broken drone. What is the area of the piece he needs, which is pictured below? You just need to find the area of this. You do not need to find the area of this little piece, which I've seen some students do. However, you could find the area of the big rectangle and then subtract that little piece, or you could divide this up into 3 rectangles and add them together. So this is really no different than the problems you've already done, 1 through 8. And then the last section, this is quite simple. This is on how to estimate the area of an irregular shape. So you can do that two ways. We place a grid over top of the irregular shape, like let's say it was a lake or a pond. You can do it by dividing that up into polygons that you know how to find the area of, and then you could calculate each of those separately. That's method one. That's the longest method. Or you can count the squares that are shaded, and you can estimate like partial, like decimal amounts for those that are not completely shaded. For example, in 11, I would count this square here as half a square, and I'd count this as a half a square. So these two squares together would be 1. And then the full squares I would count, 1, 2, 3, 4, 5, 6, 7. Those are almost completely filled. And then I would add the fractional parts after that, maybe saying these two could go together to be 1, these two could go together to be 1. So you can either count and estimate, or you can do this more complicated method of actually dividing it into polygons and then using the formulas to find the areas of those polygons and then add them together. All right, that's it for this lesson. Make sure you show your work and have a wonderful day.